So in the last episode, we worked on the re-implementation of Ed in Rust. Um, for a quick side note, I also renamed the project to Red because I was playing with the thumbnail of the last episode and I placed the Rust logo. Then I typed Ed because we are implementing Ed and it read as Red. And I thought that was a great idea, better than TE, which stands for text editor. That was dumb. So Red sounds good. So in this episode, essentially what we are going to do is implement a range for the command. So let's take a look at ed, the real thing. For example, I'm going to append line 1, line 2, line 3, and I'm going to quit out of write mode. And if I do comma L, it prints the entire buffer. So comma with no numbers means it's a complete range. And if I do 1 comma 1 L, it prints the first line, and 1 comma 2L, it prints both the first and the second line. So it's essentially the starting and the ending. So in this case it only prints the first line, and in this case it prints both the line because it starts from 1 and ends at 2, and these are inclusive, obviously. So that's what we're going to work on today. The first thought that might come to your head is using regular expression, but I am not going to use regular expression. The reason being, it is a little bit complicated for given such a simple task, in my opinion. So we are gonna not do that. Instead, we are gonna use a lexer. So we are gonna analyze the given input lexically, and we're gonna split it into tokens. And using the tokens, we are gonna do that. So essentially, what I thought was, let's say the command 1 comma 1 L, and I'm gonna lex it into something like number comma 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 number comma word. So essentially we're going to convert this into this. So we're going to read it as number. So let's say if it was 23 to 35, for example. Let's take a really good example. This whole 23 will be treated as a number rather than 2 as a number and 3 as a number. So that's the advantage of doing it lexically. And we can essentially extract the 23 and we could treat it as one value, and we could read the comma as comma, and we are going to treat the 35 as a number, and L. So if it was L and ASDF, for example, it's going to treat the whole thing as word. That's how lexer work. So we are going to essentially do that. So without further ado, let's just get started. So the very first thing that I'm going to do is edit my vimrc, uh, simply because it lacks. Every time I need to do source this file, so I want to get rid of that. I'm going to abuse auto command essentially. So let's take a look at auto command. I'm looking for some example. Buff read, yeah, that should do. So it's rs call config. So essentially, what I want to do is every time I open a Rust file, I'm trying to overwrite the default file type behavior. So that should work. Open red. There you go. So what is the make program? It's make. So that works. And yep, we can make it. So I'm going to create a crate called lexer.rs. Let's just get started. So the way I'm going to implement it is as kind of like an object oriented way. So let's take string, for example. And if I go to the source, the string, um, you can see they have the struct and the implementation down here. So essentially, we can do this thing in Rust where we can declare a struct, and in the implementation, we can essentially attach some functions to the struct. So it's essentially making it a little bit like an object oriented, but not it doesn't have like the inheritance and all those, the more object orienting features. So that's how it's going to be. Excuse me, sorry about that. So let's just get started. So I'm going to call it as struct, and I'm going to call it as lexer, obviously. And let's think about the things that it's gonna have. It's obviously gonna have the code, which is gonna be a owned string. So the lexer is going to own that. It's gonna have position, usize. So in a typical lexer, you would have like two positions denoting the row and column, but we don't need that here because essentially we are gonna have only one line. And yep, so we can have string data. It's gonna be also an owned string, and we're gonna have num data, which is gonna be also um, I'm gonna go for U64 for now. Let's see if it works. So I'm gonna go to implementation of the lexer, and I'm gonna create a new function. So I'm gonna call it pub because I want it public, and I'm gonna call it function new. So essentially, this creates a new lexer instance with code. Um, I'm gonna accept a string slice here, and I'm gonna say toString to the slice. So essentially, I'm creating a new memory here. So in a way that the lexer owns it. I'm gonna set the position to 0, obviously. So in this case, position refers to a column number. In case comparing it to the traditional lexer. So for string data, I'm gonna say string.new. I'm essentially allocating the memory, nothing else. So for num data, it's gonna be 0. So that's the new function. And what I'm thinking is, let's just also make this pop. We can have an enum of token types essentially, and let's think about the token. So as I showed in the example, we're gonna have a word, we're gonna have a number, we're gonna have comma, we're gonna have slash. The reason slash is because we will later support substitution, which kind of looks like this, for example. So here s is a word, and we have slash, we have a word slash word slash. So we will parse it like that. So that's the reason why I'm adding slash, thinking in the hindsight. And I'm also going to add end. Essentially, if the lexer fails to pass something, or we reach the end of the the code, we're gonna return the end token to denote that we are done. So I'm gonna create a public function called next. So essentially, the way I'm planning to use this function is the lexer is that, let's just see an example how I am thinking in my head of using this lexer. I'm just gonna quickly comment these things out. So, so let me just quickly comment this out. So the way I'm thinking is, we have a lexer. Let's call it lex equal to lexer. So first of all, I need to import the crate, and also need to do use. I think that's how we do that. I'm not sure. So I'm gonna have lexer. No, I think it can just do that. Okay, let's just check the compilation error for that. I'm not sure. And I'm gonna have a token, and I'm gonna say lex.next essentially. So we're gonna take the first token, and we loop till our token is not a end token essentially. So this is how I am planning to iteratively go through each token. And here obviously we update the token. So we go through the token until we reach an end token. And here for now I'm just going to debug print the uh, token, for example. I'm gonna say token is that. I'm also going to put the print statement here. So this is how I'm planning to use the lexer. So this is how the after we implement the lexer, this is how it's gonna look. So with that in mind, let's try to implement the lexer. Obviously, we get the self here. The self means we are going to essentially get the instance of the struct here. It's supposed to be mutable self, but let's make it mutable later. and there is no arguments. So I'm just going to straight away return an end token. If nothing fails, it's going to be end. Let's also check for the boundary condition. Um, if self dot position is greater than or equal to code dot length. Essentially, if we are at the if we exceeded the if the index exceeded the thing, we are going to do that right away, and we are going to get the chars. So in order to get chars from string, we need to use the chars function, and we need to use the end. Take a look at this example. So it's gonna return sum. So we need to extrapolate that. So let's just do that first. So I'm gonna do if let sum c equal to, yeah, it's chars dot end. So I'm gonna do self dot code dot chars dot end, and I'm gonna do self dot position. So we are extracting the character, and we are kind of unpacking the sum in a way, in a safe way. So if we unpack successfully, we need to do something. So the first obvious thing we can do is check if it's a comma, because that's something we can directly do. We can directly return the token type as comma. We should not forget to increment the lexer. So I'm gonna do self dot position. We can increment this by 1. Now we can set this as mutable because we are mutating it. I'm gonna do the same for slash. I'm just gonna change this to slash. Here we go. So if it's neither slash nor comma, it could be either a number or it could be a word. So that's the only possibility. So let's do for a number. So in order to check for a number, the way we pass the number is we check if the current position has a digit, and if it has a digit, we loop till we encounter a non-digit. Essentially, let's take an example of 1 2 3 foo bar. So let's say the position is here. The position is here. What we do is we loop till we see digits, and when we encounter a non-digit, we are going to return the token type as number. So the buffer is going to contain these digits essentially. So that's how we do. So in order to check whether the current character is a digit, we need to use the ASCII chars function. Let's take a look at the signature for that. ASCII char. No, ASCII digit. What am I telling? Okay, we need to use ASCII digit. So what this function does is it returns false when it's a character like A, G, but it returns true if it's a digit from 0 to 9, for example. So this is the perfect function for us. So we're going to do if C dot is ASCII digit. Can I copy this? It would be nice. So if it is an ASCII digit, we are going to pass it for a number. So let's just do that. So right away, I'm going to increment the position as 1, and I'm going to set the digit num data to the current digit. So the way we set it to the current digit is essentially very simple. We're going to take the ASCII value, let's say 2 for example, and we're going to subtract it with the ASCII value of 0. So what you need to know is, regardless of its ASCII or UTF-8, it doesn't matter. The numbers are in a contiguous way. If 0 is, let's say, for example, let's say the ASCII value of 2 is 23. This is not the actual ASCII value, I'm just making it up. The ASCII value of 0 would be 21. That's what I mean by contiguous. So ASCII value of 1 would be 22, 2 would be 23, 3 would be 24. So essentially, if we can subtract these two values, we would get the absolute integer value of the, whatever the thing that is in the string. So that's what we are going to do. And what did I declare as num data? Yeah, I declared it as i64. So the way we should do it is we set C as i64 because that's the data type, and I'm gonna minus with 0 as i64. So that's what we're gonna do, and we need to keep on going. So I'm gonna do a while, and we need to essentially do this thing. uh, while it is a digit, while character is a digit, but we should not do it as character as a digit. Let me think about it here, because C is something that we unpack. You need to unpack it again. I'm gonna call it as n equal to. You need to do the same thing that we did above uh, again. So if n, we unpack this. Um, Maybe we do it in the same way that we done above. I think that would make sense. Mm, Let me think about how to do that. I mean, I have the logic in my head. I'm just thinking about the Rust way of doing it. So n, essentially we need to check if n is a digit. That's what I want. But I think this is an invalid Rust code. We can't do something like that. Hmm. I want to do something like this. You know what? I'm gonna ask ChatGPT how to do. Oh my god! It's asking me to log in. That's cringe. I'm gonna go to Google AI then. Um, go to AI mode. Uh, how to do something like this in Rust. I mean, this is what I mean. I got the logic, but I'm not sure about the Rust way of doing it. Hmm. Okay, there is something called as loop. Okay, I never knew that existed. Hmm. That seems interesting. Let's try that. Why not? So, what it is saying is we are gonna do if gonna put it as in loop, and if some n. Okay, so what it is doing is, okay, this syntax is very interesting. If this is true, it passes through there. Otherwise, it's gonna do this. I never seen this syntax before. Oh my god, that's interesting. Okay, you know what? We learned something new today. Okay, so let sum n equal to that. If it's not true, we are gonna break. Uh, that means we reach the end of the string. This is really cool. Oh my god! I mean this is really hacky. There is no if, but we have else. That's kind of weird, but I can understand what's going on here. Well, Rust has a lot of magical syntax like this. This is one thing I kind of like about Rust. You know, one positive thing that I can tell about Rust, and we can essentially check it as a digit. I'm gonna essentially copy paste this logic here because what's the point of retyping it here? Okay, so if you got a digit, we need to first of all increase the position like so. Um, if we found a digit, what we need to do is, first of all, we need to multiply the num data by 10, um, and we need to add it. So I'm going to copy this code, paste it. We need to increment by n. So essentially what we are doing it is, let's say for the first iteration the number is 1 2 3. Assume that. So the first, when it comes here, in the buffer 1 would be entered, and then what we are doing it is we are multiplying it by 10, so it becomes 10, and we are adding 12, so it becomes 2. Then we are multiplying it by 10, and we are adding 3, so it becomes 1 2 3. So that's how, this is a very typical lexer way of doing it. So if you have ever written a compiler yourself, you might, this is very familiar. This is a very, you know general way of doing it is. So if it is neither, we're gonna just pass it as word. So what I am going to do is, I'm gonna essentially copy this code. I'm gonna do a little copy pasting. uh, You know what? Let's just keep it as n, and yep. And we need to do self dot stir data dot push bn. Yeah, that's how we append that. And I also forgot to do that here. C, need to do increment. There you go. So that looks pretty solid to me. And I kind of forgot one thing also. We need to clear the data every time the function is recalled. Um, no, we can do that here. Who said we can't? So I'm gonna say self dot stir data dot clear, which clears the string buffer, and I'm gonna set the num data to 0. So let's clear out the num buffer also. So that looks pretty good. Let's see whether the compiler is happy with that. Obviously it's not. Hmm. Okay, it requires a semicolon. I didn't see that. So let's quickly add a semicolon there. Code is there, not there. So we need to do a self here. I'm gonna quickly comment out that. Okay, we need to return a lexer. Did I miss the return type here as well? Yeah, we need to return a token type. Let's see. Okay, we need to pass the CMD. Yeah, we need to pass the CMD. What else? Okay, we didn't implement the debug trait. So even the compiler tells us how to do that. So I'm gonna essentially copy the code from the compiler error and I'm gonna paste it here. Why didn't it copy? I'm gonna take an atom 2. There you go. Um, we might need to add a partial equal. So let's also do that. There you go. What else you want? Mm. Okay, it's complaining about unused variable. Cannot be mutable. Okay, we come to the actual errors here. Let's make this mutable. Okay, we need to make this mutable. What else you want? Is there any error? Nope, there doesn't seem to be any error. But there's a warning that we didn't return any word. That's sus. We need to return token type dot number here, and we need to return token type dot word. Obviously. Yep, that compiled. Okay, that didn't even really cause any warning there. I'm gonna remove the red. I'm gonna make it again. Okay, so we get some warning. So it didn't compile properly. Okay, so let's just take a look at the output then. So I'm gonna create a main.c for example, and I'm gonna open it with red. Okay, it didn't compile. I'm gonna do ASDF, and it compiled as 2 words. That's something that I didn't expect. What if 123 ASDF? That's not working the way I intended. In order to debug, I'm gonna match it um, rather than doing it like this. Um, um, how should I do that? I don't want to implement a function called token print. That's a little bit cringe. Mm. Uh, how do I do that? You know what? I'm just gonna match it and see what happens. I'm gonna match it as token type dot word. In that case, I'm gonna do a println saying it as word. I'm gonna print the word data. I'm gonna say lex dot stir data so that we can actually see what our thing caught. So if it's a number, obviously do the same thing. Number. If it's neither, we are just gonna you know do a debug print on it. Why not? That seems fun. So yep, it's complaining that we are accessing private things. So I'm gonna make these both public quickly. New space. So I'm gonna do red to make. We only get errors. So we've only got warnings. So I'm gonna do red. Red main.c. I'm gonna do ASDF. It says word ASDF. Really good. So I'm gonna do 123 ASDF. So it says number and it's not printing anything. That's weird. Um, okay, we need to print num data here. My bad. I just copy pasted it blindly. I'm gonna retest it. So I'm gonna do that. Uh, make that ASDF. A word ASDF. I'm gonna do 123 ASDF. We got 123 ASDF. Let's check 12 ASDF and a 3. There you go. We actually implemented a lexer that can break down these things. This is what I mean by regular expressions are a little bit over complicated for this. As you can see, our code is really pretty much very simple. It just took like 83 lines of code, and implementing a regular expression would be a little bit more complicated than this. Even though we might not need to write the code, the actual code that runs in the runtime is actually very complicated in order to achieve a very simple task, in my opinion. So that's what I mean. uh, we could use Alexa. Okay, so let's just put this thing to a real use, shall we? So what I'm going to do is, we would get a token. So what we might have, what we need to do is, we need to check whether the token is a word directly. So essentially we have three cases: whether it's a direct command. So for example, it's just L. That's a direct command, so it has no range, and it has half range. When I mean by half ranges, it has comma L or comma 2L. These are all example for half frame. You know what? I can put example here. Maybe that would make it a little bit clear, and it can have full range. Example 1 comma 3L. So these are all the different types of possibilities there is for a command. So we are going to handle these things differently. So what we am going to do is, I'm going to check it if the token is a word. That means it's a direct command. So what I'm going to do is, and we are going to just essentially execute this thing here. So I'm gonna steal this code. I mean, I'm not stealing, I wrote the code, so that's legal. So we're gonna do write, and I'm gonna preserve this code for now. So yep, get rid of that. There you go. So that's what we're gonna do. So it's essentially a full command. It's either A, it's either W, or it's just L. Okay. So in case of a half command, and we might also need to assert whether it's the end of the token, the next thing, but let's just leave it like that for now. It doesn't really matter. So in case of an half command, what we should expect is it's a comma. Okay, and you know what, I'm gonna implement half command later. I'm gonna just implement full command. The reason being, implementing full command already kind of implements half command in a way. uh, you will understand what I mean. So we check it as a number. So essentially we are checking this token, and we get the next token, and we check if the token is uh, comma, You know what? We can use a new syntax that we learned a second ago. I think that would be useful. Uh, no, no, no. That syntax won't work here. Okay, what am I saying? Uh, Never mind. I have some thoughts running in my head. So if it's a comma, what we gonna if it's not a comma, essentially we need to print this question mark and we need to return. Yeah, we need to return. Essentially, we need to get out of this iteration. So we expect a comma essentially. So before we call next, we need to maybe put first, and I need to preserve the um, number value, uh, num data. Yeah, we need to preserve the num data. Now I'm thinking I need to instead of I64, I'm gonna keep it as use size. So I'm gonna keep it as use size just to make things consistent. You will see why. We might run into some issues later. And now that we got that, I'm gonna pull the next token. I'm gonna copy paste this if condition. We expect it as a number this time. It's number. We're gonna return an error, and we're gonna do uh, what am I saying? Num data. So essentially, the first now contains one, for example, and the second now contains three, for example, and we need to do the same. Maybe we need to make this into a macro. So we expect a word. If it's not a word, we're gonna throw an error, and we're gonna essentially run a match here. So I'm gonna copy the match block here. We don't need everything. We only need the um, L. So in case of an L, which essentially means list, uh, we might need to use that. I think that's a better example. So what we need to do is we need to take a slice of L from start to end, and I think it's um, start minus 1. Uh, why am I not getting start autocomplete? Okay, I named it as first. My bad. First minus 1 and last minus 1. What am I saying? It's second. Okay, my brain is not braining today. Okay, so it's first minus second. So I think because if the user may stays 1 comma 3 in the array index, it means 0 comma 2. That's what I mean. That yeah, that should work. And we don't need it as comma. We just need it as L. I'm gonna add else here. Let's just try to compile this for now. Let's see if we get any error. Expected 1 of dot. Okay, so there should be 2 dots, I assume. Right. Okay, I need to uncomment this. Remember we commented that temporarily to make the compiler satisfy. So let's just test it. So I'm gonna also make sure I compile the right thing. I'm gonna test. I'm gonna append some things. Um, am I still printing it? Why do I get word here? Okay, the print code is also working. Let's just ignore that. I'm gonna say line 1, line 2, line 3. I'm gonna put that. I'm gonna do L. Okay, so the L didn't work. Let's try it again. Line 1, line 2, line 3. Does comma L works? I mean 1 comma 2 L works. Okay, so I need to exit out of write mode, obviously. And it printed a question mark. That's interesting. First of all, yeah, this thing is creating a mass confusion because there is a token dot next which kind of ruins everything. Should not do that. Maybe we need to do that. Wait, let me check. Mm, yep, we need to just get rid of this. Um, yep, that seems like the right thing to do. And match CMD. I'm just checking the indentation levels whether they are correct. Okay, seems like correct. I'm gonna do that. A line 1, line 2, line 3, dot, comma L. That asks for a question mark. That's understandable. And comma to L. That also asks for a question mark. That's not expected. But if I do L, it crashes. Let's take a look at the error. It says the length is 3 and we are getting the index of 3. So L is a direct command. So let's come here. Um, we are essentially doing this line in the append. Um, I think finally we need to subtract a line. Isn't that how it's supposed to work? A line 1. Okay, now that, I mean, not here, sorry. Um, here. Okay, here. I meant when we type a dot, we need to subtract a index. Why didn't I do that earlier? I'm not sure. Line 1, line 2, line 3, dot. I'm gonna do 1 comma 2 L. Okay, that didn't work. Line L. Okay, L works, but that didn't work. Let's just take a look at why it didn't work. So it failed at either one of this. So let's put a comma here. Let's put number here. And let's put a word here. To distinguish, to see where it exactly failed, obviously, I'm going to do line 1, line 2, line 3, dot. I'm going to do 1 comma 2 L. Okay, just print question mark. That's really weird. Maybe it failed here. It can't recognize here. Just also make sure that works. 2 dot 1 comma 2 L. Yeah, it failed here. That's kind of weird. Hmm. In this case, I'm gonna print the command that we got. Um, okay. I made a mistake. Okay, I made a mistake. I found why. So I'm gonna remove all these debugging things that we did. We should not match for command. Obviously, we need to pull out the, let's call it C, equal to lexer dot stir data dot to string. So we need to pull this slice and we need to match for that, obviously. um, to str is not that. How do you convert string to slice? I actually forgot. Let's take a look at string. How do I get a slice of the string? There is only two string, there's not two str. Okay. um, as by its as string. Okay, it's as string, not two string. Okay. Okay, that makes sense. And let's try this one more time. Dot 1 comma 2 L. And that didn't seem to work the way I expected it to work. That didn't print anything. That kind of makes sense. We kind of messed with the range. Maybe it's like that. Slices are, we need to give the next element, and it's not inclusive. Maybe that's the issue. Let's try. Line 1, line 2, dot 1 comma 2 L. Yep, that worked, and that worked. And L points to line 2, the end of the line. So we kind of implemented full range successfully. Now half range is really easy, so that's why I said I'm going to implement full range first. Essentially, the half range won't have this part. Let me see. Uh, so essentially, for the half range, we are going to only have the second. It's going to be a mutable, and the second by default points to cmd.length. Uh, is it cmd.length? Um, just a second. Not cmd.length. Okay, it's the number of lines. So what is it? It's state dot lines. Okay, I was just scrolling to see. So it's state dot lines dot length. So essentially, it points to the last line. So as we learned from this, the the range, the slice range are not inclusive. So we need to include the next one. So this is correct. But if we get a number by any chance, we might need to pull the number uh, from the lexer. Uh, did we call it lex? We called it lex dot num data. We might need to pull that, and we might need to proceed to the next token, and that works. We expect a word, we check for the word, and here what we do is we essentially, instead of from the first, we just do 0. I think that's all that we need to do. Let's take a look at the compilation error. Value assigned, never read. What do you mean? um, Value assigned to token is never read. That's really strange. um, I'm just doing the same thing. It's a warning, but unused assignment. I mean, I'm updating this, right? So it should work. You know what? I'm just gonna ignore the warning and see whether my code actually works. So I'm gonna do a line 1, line 2, line 3 dot. So if I'm gonna do 1 comma 1 L, it obviously works. Comma L, that gives an error. That's a little bit strange. What about 1 comma 2L, comma 1L? Okay, clearly our half range is not working. That's for certain. So let me just revise. So I'm just taking the length here. If it's a number, I mean, if it is a number, I need to check for a number. Okay, that's the first mistake I made. I'm skipping to the next token, and if it's a word, I mean, if it's not a number, let's say if the token is not a number, it's straight away going to this. Um, okay, we don't need to do that. Yeah, that works. Okay, let's do that. I'm not sure about the warning, but that statement was a mistake. That was a logical mistake. So let's do line 1, line 2, line 3 dot. Let's do 1 comma 2 L. It works. L works. Comma L works. Okay. Comma 2 L. It works. Okay. That's exactly the behavior that we want. Let me open. I mean, I don't want that. Okay, let's do it in this split itself. Let's see how the ed behaves to compare the real thing that we are trying to recreate. Line 1, line 2, line 3 dot. If I do 1 comma 1 L, we get the first line. 1 comma 2 L, we get the second line. Comma 2 L does the same thing. Comma L prints the entire buffer. We essentially recreated the feature by ourselves. That's really good. I'm just gonna do a little bit of cleanup. Uh, is there any more things that I did? Okay, there we go. I'm gonna essentially commit the change. Added uh, parsing ed commands, and I'm gonna officially push that. Um, why is my hotkey not working? There you go. We pushed the change. So that's it for today's episode. In the next episode, we might add support for search and replace. That's what we're gonna do in the next episode. And yep, see you in the next episode. Adios, amigos.